Hi guys, it's me again. So, in our previous video, we have solved 4 exact differential equations. This time, I'll be introducing to you the integrating factor. So, an integrating factor is a function used to solve differential equations. It is a function in which an ordinary differential equation can be multiplied to make the function integrable. So, in integrating factor, we have two results and they can be expressed as these following rules. We have d I over n times the partial of m in terms of y minus the partial of n in terms of x is equals to fx. If this is used, or if the function is x alone, then the integrating factor that we'll be using is e raised to the integral of f of x dx. As well as in the second rule, which we have 1 over m times partial of m in terms of y minus partial of n in terms of x is equals to g of y. So if this is used, or if the function is y alone, then our integrating factor, or the integrating factor that we're going to use is e raised to negative g of y dy. Okay, so let's further expand the concept of integrating factor by solving problems. Here we have the first problem, which is 2y squared plus 3xy minus 2y plus 6x dx plus x times x plus 2y minus 1 dy is equals to 0. Let's first expand this equation. So we'll have x times x is x squared, x times 2y is 2xy, then x times negative 1 is negative x. Now let's check for exactness. We're going to use this one to solve for the partial of m in terms of y. So we're going to derive this with respect to y. Then we'll have 4. Then we're going to use this one to solve for the partial of n with respect to x by deriving this with respect to x. As you can see, they are not exact. So we're going to use an integrating factor. It's hard to identify which integrating factor we're going to use, or which integrating factor rule is much easier to solve, but in this problem I think we're going to use the n, which is this one, since this looks simpler. So we'll have this one, then just substitute it. Our n is our partial of m in terms of y, this one, then our partial of n in terms of x, this one. Now let's distribute this negative sign inside this parenthesis. And let's combine like terms. Let's start with x variable. 3x minus 2x is simply x. 4y minus 2y is 2y. And negative 2 plus 1 is negative 1. This can be cancelled out. So our g of y will now be 1 over x. Then we're going to use the integrating factor. If is equals to e raised to the integral of f of x dx. We substitute the value of f of x, then solve. Using the logarithmic rule for exponent, this will be cancelled out. Then our integrating factor now will be x. So this integrating factor, we're just going to distribute this in our equation. Now we'll have a new equation which is 2xy squared plus 3x squared y minus 2xy plus 6x squared dx plus x cubed plus 2x squared y minus x squared dy is equal to 0. Now let's test if it is now exact. Derivative of 2xy squared with respect to y is 4xy plus 3x squared minus 2x is equal to 2 is equal to 2x. I mean 3x squared plus 4xy minus 2x. Now, as you can see, both sides are equal, so this is now exact. Now let's proceed to the next step. We'll have the function of x is equal to m over r 2y squared plus 3xy minus 2y plus 6x dx. Integrate both sides by dx. Move out the constant. Then integrate. Now we'll have f is equal to 2y squared x squared plus 3y. Sorry, there is a bit of mistake. Minus 2y x squared. Oh, I forgot to insert that one. Plus 6x cubed So instead of the arbitrary constant, we'll be using unknown function. Then let's simplify this. This can be cancelled out, so x squared y squared x cubed y x squared y plus 2 x cubed plus g of y. Now let's derive this function with respect to y. So we'll have the derivative of x squared y squared is simply 2x squared y. Derivative of x cubed y is x cubed only. Derivative of x squared y is negative x squared. Derivative of 2x cubed is 0. And the derivative of g of y is g prime of y is equal to Rn, which is x cubed plus 2x squared y minus x squared. Then since this can be cancelled out, let's cancel that out. So our g prime of y is 0. Then integrate both sides by dy. Then we'll have g of y equal to 0 plus c, or simply c. Now let's copy our function. Let's have function is equals to c. So copy our function x squared y squared plus x cubed y minus x squared y plus 2x cubed. Then let's substitute the value of gy with this one. So it can be c or plus c or equal to c. Then simplify this expression. Then we'll have x squared that's it. That's the final answer. Now let's proceed to the next problem, which is this one. Let's first expand this equation. Then let's test for the exactness. This is our partial of m with respect to y. Then our partial of n with respect to x. Since this is not exact, we're going to use an integrating factor. But this time, the most closest will be our m. So we're going to use this rule. Just substitute. Our m here is this one, okay? Then distribute the negative sign inside the parentheses. Now combine like terms. 2x plus 2x is 4x. 3y squared minus y squared is 2y squared. Then simplify this one. We'll have this can be cancelled out, so our g of y now will be 2 over y. Now let's solve for the integrating factor. We'll be using negative integral of g of y dy. Just substitute. Since 2 is constant, we'll be moving that out. Then we'll now have solve. Now our integrating factor now will be y raised to negative 2. Now let's distribute this inside our equation to form a new equation. Then we'll have 2x y raised to negative 1 plus y dx plus x y squared times y raised to negative 2 is y raised to 0 or simply 1. So we're just not gonna write that down. Minus x squared y raised to negative 2 dy. Now let's test for exactness. As you can see, this is now exact, so we can proceed to the next step. Let's solve for the f of x, and we'll be using this one. Integrate both sides by dx. An unknown function instead of the arbitrary constant. Then simplify. Now we're going to derive this one with respect to y. So we'll have partial of f in terms of y equals to the derivative of x squared y raised to negative 1 is negative x squared y raised to negative 2 plus derivative of xy is simply x, and the derivative of g of y is g prime of y equals to our n, which is x minus x squared y raised to negative 2. This can be cancelled out in this one. So our g prime of y now is 0. Equate both sides by dy. Then our g of y now will be 0 plus c, or simply c. Then to get the final answer, copy the function, this one. Then substitute this g of y with this one. So we'll now have x squared y minus y raised to negative 1 plus xy plus c or equal to c. Now, let's bring this y down so the degree can be positive. Then we'll have multiply both side by y. So we can simplify this equation. Cancel that out. Then we'll have x squared plus xy squared equals to c of y. Then simplify again. We'll now have x plus y squared is equal to cy. And that's our final answer. So that's it with the integrating factors. I hope that you've learned something, and of course guys, please subscribe to our channel and please support us by watching our other videos and liking them. That's all. Thank you.